Alright men, welcome to How to Tell if a double replacement reaction will happen or not. I'm towards the end of the Unit 6 notes here. And the question today is, when I come across a double replacement reaction, how do I know if the two substances will react or whether they will just sit there and nothing will happen? Basically, you gotta meet two criteria for a double replacement reaction to happen. Rule number one, at least one of the reactants, or the things on the left, must be able to be dissolved in water, so it must be soluble. The way we indicate that is with a little AQ to mean that it is in the aqueous state. In other words, it's dissolved in water, or the ions are separated apart in water. If things cannot dissolve, we give them a little S, which means solid in water. So it's kind of confusing because some people think S means soluble. It doesn't. S means solid, L means liquid, G means gas, and AQ means aqueous, or dissolved in water. Okay, the reason for that is simple. It's just for molecules to react together, the molecules physically have to bump into each other, and that's kind of hard to happen if you have two solids. Like, you don't usually just set two solid bricks next to each other and actually get a chemical reaction. So it's a soft rule. There are exceptions to it, but in general, at least one of the substances has to be dissolved in water. So we'll just simplify it and say that it's a rule, because it is difficult for two solids to react. One exception to this rule was when you were doing ice packs and hot packs for endo and exothermic reaction lab, and you mixed two powders together, rubbed them together, and they got cold. Well, those were two solids reacting, but usually we facilitate a chemical reaction by dissolving it in water for a double replacement reaction. Okay, rule number two is more severe than that, and rule number two says at least one of the products must form a precipitate in water. At least one product must form a precipitate in water. Now, why would that have to be? Well, first of all, a product means a substance over on the right, something you're producing. Precipitate, literally the word precipitate means to fall. Like you might say in sports that a guy had a precipitous fall at the end of his career, he kind of nosedived. Or if it's precipitating outside, precipitation might take the form of snow or sleet or rain, but they're all things that fall from the sky. And we use this word in chemistry to mean something that forms a solid in a solution, and then that solid sinks to the bottom of the beaker, or falls out, or precipitates out. So a precipitate, another word for it, is just a solid in solution. To explain why, I'm going to draw a picture of this reaction here, where we have silver nitrate reacting with ammonium thiocyanide to produce silver thiocyanide and ammonium nitrate. Okay, here's the beaker at the beginning. Because I have an AQ after AgNO3, I know that the Ag ion has separated from the NO3 ion, and they are floating around separately or dissolved in the solution. Likewise, NH4 is separate from SCN because it's labeled aqueous, AQ. So I've got NH4 floating around separately from SCN-. That's a polyatomic ion. Okay, That's before the reaction. Let's look at the after reaction beaker. Same beaker after the reaction. And let's imagine for 1 second that a silver thiocyanide was labeled with an AQ. So maybe just watch this, but don't write it down yet. Then I would know that silver and SCN were separated, or the Ag plus was floating around separately from the SCN negative. Likewise, NH4NO3 is aqueous, so the NH4 is floating around separately from the NO3 negative. Now look at this before and after picture. At the beginning I've got 4 separate ions floating around, and at the end I have the same 4 ions floating around independently. Nothing has changed. And if nothing changes, that's not a chemical reaction. In other words, if I didn't make any solids over here on the right, I didn't get a chemical reaction. What I need to happen in order for a chemical reaction to occur is the way it's written here, and at this point maybe you can start copying this down. The Ag and the SCN form a solid. So the Ag gets together with the SCN, they sink to the bottom, and they form the precipitate AgSCN. That's a solid, it sinks to the bottom, and now I've actually made something new. I've made a product. So in that case I have a double replacement reaction. So again, the rule was at least one of the products, or things on the right, must form a solid or a precipitate and sink to the bottom. Otherwise you don't have a change and you don't have a chemical reaction. So to check and see if a double replacement reaction will occur, I need to first write the balanced equation. I need to label each of the substances as either aqueous or solid, and then check it against my 2 rules. Do I have at least one aqueous on the right? Do I have at least one solid? Oh, sorry, I said that wrong. Do I have at least one aqueous on the left? And do I have at least one solid on the right? If so, I'll have a reaction. If not, I will not have a reaction. Okay, the final issue, I guess, is how to label something as either aqueous or solid. You actually already have the sheet to look this up. I put it on the back of your activity series. So if you flip to the back of your activity series, there's a list of ions that are usually soluble, but then each of them has an exception next to it. And then below that there's a list of things that are usually insoluble, and each of those has an exception next to it. So let's practice by looking up AgNO3 and seeing if we can look up the fact that it's aqueous. Now you can look for either Ag or NO3 on the left column of that sheet. You'll see NO3 towards the top. Nitrates. It says nitrates are soluble with no exceptions. Soluble means it can dissolve in water, and so I label it AQ. If you want to write this down, go for it. Soluble will mean aqueous. Insoluble will mean it will not dissolve in water, and so we would call it a solid. That's it, guys. You can try an example problem here with nickel 2 chloride and sodium carbonate, and try to see if it'll happen or not, and pause it and check back, and I'll give you the answer. Okay, welcome back. Here is the balanced double replacement reaction. Nickel I saw was a +2 because of the Roman numeral 2. Chloride is a -1. Sodium is a +1. Carbonate is CO3 -2. So I have NiCl2 plus Na2CO3 yields NiCO3 plus 2 NaCl. Okay, to check and see if this reaction will occur, I need to look up their solubilities. Now, chlorides are soluble with no exceptions. Find that on your chart. Sodiums are soluble with no exceptions because they fall under the first rule that says group 1 elements. Sodium is in group 1 of the periodic table, so I'll label it aqueous. Now, suppose you didn't see that, but you found carbonate towards the bottom of your sheet, and it says carbonate is usually insoluble. Well, that's true, but there are some exceptions listed next to carbonate. It says it's insoluble unless it's bonded to the following things. One of them is a group 1 metal. In this case, we're bonded to sodium, a group 1 metal, so that flips the rule and makes it aqueous. Nickel carbonate. Carbonate is usually insoluble. Nickel is not one of the exceptions, so I'll label it solid. Also, the problem tells me that it's a blue precipitate. And NaCl is aqueous. We know that from our own experience, or from the first rule it says group 1 elements are always soluble, or chlorides are soluble. Okay, now that we've labeled them all as AQ or S, I just have to apply my two criteria. Rule 1 says I have to at least be able to dissolve one of these reactants in water. I've met that criteria. I've actually dissolved both of them in water. And rule number 2 says I have to at least form something new. I have to make a solid, at least one solid over here on the right. And I have done that, so I will have a reaction, and this would be a yes. All right, man, that's it. Hopefully that'll help you be on the lookout now for any double replacement reaction to tell if it will happen or if it will not happen. Thanks.